Okay, I would like to welcome everybody to this second section of today's event on autonomous transport and smart mobility. Now, this second section of the event has also people that have connected over the net, over the web. As I see from the program, we are having 5 very interesting interventions and talks. So we can start with, first of all, let me just, for the people on the web, let me introduce myself. My name is Nikos Vetikos, and I'm a professor at the National Technical University of Athens, School of Naval Architecture and Marine Engineering. And said that, let's first hear from Albert, who is the Innovation Project Manager at CARNET UPC. So Albert, the floor is yours for the next 7 minutes or something like that. Okay? Thank you very much.
Okay, good afternoon, everyone. Thank you for this opportunity. My name is Albert Borreguero. I am industrial engineering and currently project manager at CARNET Barcelona. And in this session, in collaboration with Fabio Antonialli, researcher at École Centrale Lyon, we will present the decision tool called .mobi. This tool was developed within the framework of ArtMED, a project under the Green Living Areas mission aimed at transforming public transportation in sparsely populated regions of the Interreg Euromed area. So this MOBI tool was designed to support policymakers, transport operators, and mobility planners in evaluating demand-responsive transport or autonomous mobility on demand services. So to begin with, let me hand the presentation over to Fabio, and he will show you a teaser video of the tool. And then we will do a hands-on demonstration so you can see how the tool can be used.
Perfect.
The iPhone Air is Apple's first true iPhone.
Can anybody hear me? Can you hear me?
Yes.
Okay, perfect.
Yep.
Very good.
Go ahead.
So, good evening, everyone. Thank you, Albert, for your words. I would like to quickly show you the teaser video. I see that it's running in the background in the room that you are in, but I will quickly play it for you, and then I'll give the floor to Albert as well, so we can show you a little bit of a hands-on experience with the tool we've developed. So I'll quickly share my screen, and then I'll show you the video.
In many Mediterranean regions, public transport is rigid, underused, and often unsustainable. Local authorities need smarter tools to deliver flexible, low-impact mobility services. Discover .mobi, a smart online platform that helps you design autonomous mobility on-demand services tailored to your region. It's flexible, it's modular, it's data-driven. Log in, define your region, simulate your fleet, and analyze key performance and cost indicators. Whether urban or rural, .mobi adapts to your needs. With .mobi, local planners gain the power to assess feasibility, sustainability, and impact, all in one place. Ready to transform mobility in your region?
All right, so now I give the floor back to Albert so we can continue with the hands-on demonstration.
Thank you, Fabio. So now that you have seen the video, let's move on the hands-on demonstration. While Fabio prepares the tool, let me explain the fictionalized scenario that we have created to help you contextualize how the .mobi tool can support decision-making. So this scenario is set in the coastal city of Lyon in the south of France, which includes a surrounding lower density rural area. And in this city, the public transport authority has identified a significant mobility poverty use issue among its elderly residents living in these isolated rural hamlets. So the existing fixed route bus service is inefficient and does not reach key community points, making it difficult for the elderly to access vital services such as doctors, banks, grocery stores, located in the main city center. So the ArtMED project goal of promoting these green living areas is addressed by replacing this reliance on private high-emission vehicle trips with a new flexible and sustainable solution. So the first step, as you can see in the screen, is to log in and create a new project. We log in with a username and a password, and we create a new project. In this case, we will name the project Viridian Rural Elderly Remote Pilot. And the goal, as I said, is to improve the accessibility for the rural elderly population. We access to our project. And the first step, the first inputs that we have to put are the regional data that is, as you can see in the screen, to describe the characteristics of the area where the service will be implemented. The inputs are the country, peak users, etc. This kind of parameters. We have already input the numbers, so we can do this session more dynamic. So we will move to the second tab now. That is the service quality.
Yeah, just before we move it, just a little remark, Albert, so everybody you can understand. So you can see here, you have to complete all the elements. We've already pre-completed it. And there are a few extra options that you can enable. You can enable peak hours, so you can make a distinction between different types of public, different types of demand. And if you have any questions on how to complete each of those fields, you see that in front of each one of them, there's a little question mark. And when you click on it, there are a little bit help button that pops up. So this allows you to better understand how to complete the tool. So let's move on to the next one. Albert, I give you the floor again.
Yeah. Then the service quality that sets out what users can expect in terms of how often the service will be available. In this case, we have to input the max waiting time and the flexibility. This flexibility understood as the allowable delay expressed as a percentage of the planned trip duration. So in this case, we have 30%. And as you can see, as Fabio said, you have the explanation in the tool itself. Then you click save to save the progress, and then we have the fleet sizing tab. In this tab, it will calculate the number of vehicles needed to meet the service quality targets defined in the previous tab. So in this case, we can see that the number that computed the tool is 5. That is the total number of vehicles required. So we can save this fleet size and then continue with the economic analysis that Fabio will explain.
Yeah. So thank you very much, Albert. So just to make a little bit of a precision about this point, we know that many operators, they will like to either improve on an existing service or they already have a fleet. In that case, if you have a fleet, you can click this button, which is right here in the beginning, and you can type the data about your own fleet. But if it's not the case for you, if you want to, let's say, design a service from scratch, the idea is that you select the vehicle type Here we selected an internal combustion engine bus, like a minibus. We put the capacity to 8, which we were considering it to be the size of an autonomous minibus. And you can change it if you wish to an electric bus, and the hours of the service. And then you can simply save and evaluate, and this will give you the total fleet size that it's the ideal one for your service. If you want to add another fleet, you can as well. So you click here in the bottom, the button in the bottom. So you can add a different type of vehicle, and then you can compare both types of fleets that you have. So that's the idea. The tool shall be very dynamic and very adaptable to each of the situations. So once you have your fleet defined, we are going to move to the internal costs analysis. So the idea here is, again, to calculate how much would you need to invest in terms of initial investment. That would be the CapEx, right? The capital expenditure. And how much would you need to pay, or to, let's say, have as costs in terms of operating expenditures. I didn't complete all the fields. We just put a few data here so you can understand how the tool works. For example, we completed for CapEx vehicle procurement, so you have to purchase those vehicles. Here we put the price of 180,000 euros for each vehicle, and you can select if you want to do it by vehicle, per fleet, per passenger, per kilometer. So it depends on the number you are computing. And then you can just complete all this data here. If there's anything you'd like to add that is not in this predefined data, all you have to do is click on add a field, as you can see right here, and you can create a new field and put a new source of costs. This works, of course, for the capital expenditure and for the operational costs as well. And we know sometimes that operators, they don't have those numbers very, let's say, detailed or in such level of granularity. We know that some operators, they operate with cost per kilometer. So we also gave you this option right here in the operating costs. So you can add cost per kilometer, and then you can add other OPEX fields as well. So the idea is to make it as flexible as possible to fit as many different scenarios that you may encounter. And here the tool provides with you a little bit of a breakdown of how is your cost divided. So you can see here the numbers. I'm going to save and process. Then we can move to the next tab, which is the externalities. This one is automatically calculated based in the country that we've chosen. We've chosen France. So we used third-party data to calculate, based on France standards, how much this would cost for, let's say, the general public in terms of externalities. So here we are considering accident costs, air pollution, noise, congestion, so on and so forth. And then you have the cost per passenger per kilometer, per vehicle per kilometer, and how much this would cost per year. So again, it's to give you an idea of how much this would cost for the society in terms of externality while implementing your new kind of service. The other tab, it's KPI 1, and here again, it's a results tab. And then you can see how much would you need to spend in terms of CapEx. Then you have the details about the OPEX, and you have your indicators: cost per vehicle per kilometer, cost per passenger per kilometer, cost per vehicle per kilometer, with externalities as well, in case you want to have a bigger picture. So once you have all your costs highlighted and well-defined based on the parameters you entered, your fleet size, your regional data, your service quality, you can now simulate your revenue sources. So the revenue follows the same logic. You can provide as many revenue sources as you think you need, and you can complete it with data per passenger, per kilometer, per vehicle, or per fleet. In that case, we put a ticket at €1 per passenger. We consider a subsidy from the European Union for the entire fleet, and we also consider funding for European Commission for the fleet as well. So this gives us, of course, a total revenue for your working year, and then you can evaluate. It will give you the graph, it will give you the results. And in the end, the final metric that this tool calculates is the net present value. So the idea of the net present value is to tell you, given the amount of years you would like to calculate, if your project covers the costs, if it's profitable or not. In that case, we took into account a 2% interest rate, a 2% growth in terms of revenue for your service, and we took into consideration return over investment in 2 years. And we can see that the net present value here is positive, which means that the cash inflows cover the total cost of the service. In that sense, we can say that with the data we input here, this service could be feasible for the case that we are proposing. So I know it's a lot of information, a lot of details, but the idea was to briefly present to you with this hands-on experience of the .mobi tool. This tool is freely available to anyone in the ArtMED project website. And the idea is that it is there to help you to make a more informed decision whether or not implementing a new service on demand, autonomous, and so on and so forth. It is indeed a decision-making tool there to accompany all stakeholders who are willing to innovate and to implement different services for public transport. That would be all from our part. I would like to thank you for your attention. And of course, we open the floor if you have any questions.
Thank you. Thank you very much. Thank you, Albert. Thank you, Fabio. I didn't realize that you will both be doing the same presentation. So apologies for not introducing you, Fabio.
No problem.
Fabio is a researcher at École Centrale Lyon, associate professor and bachelor program director at PPA Business School in Paris. Very nice. As I understood, this tool is freely available. How many downloads have you up to now? How many people are actually,
The tool actually, it's not a download-based one. It's like a website, right? So you just have to connect yourself and create a login, and then you can use it on your mobile phone, on the computer. So far, we recently launched it, so it was officially published in the end of July, so very, let's say, close to the summer vacation. So for the time being, there's not a lot of people using it, and this is one of the reasons we would like to introduce the tool to you. And of course, we are making it available to the general public. It's free of charge. It's always going to be like this, and the idea is that it's there to anybody that's willing to give it a try.
Okay. Thank you, Albert. Thank you, Fabio. Wishing you the best. Okay. Thank you very much.
Thank you very much.
So we will continue with Cyrille Médard de Chardon, a researcher at the Luxembourg Institute of Socioeconomic Research. Cyrille, the floor is yours for the next 10 minutes. Thank you very much.
Great. Thank you. Thank you very much. You can hear me okay?
Yep.
Yeah, perfect. Yep. Okay. So given the title of the session, I wanted to explore the potential impacts and outcomes of autonomous buses. So I'm just going to chat. I don't have a presentation to share. So the conventional bus is an effective way of moving lots of people rather than cars, which, as we see with congestion, are not super efficient. And in fact, cars are responsible for reducing our ability to move to some extent. But the problem with the bus is that the driver is actually the most expensive part of a bus service. And this is why autonomous buses appear to be such a valuable solution. So many municipalities are struggling. In the US right now, we're seeing public transport services being reduced. Autonomous buses could allow us to maintain or even increase bus services. And for those familiar with Jarrett Walker, his expression is frequency is freedom. And this is really what autonomous buses could potentially provide, is greater freedom if we get that frequency going. But let's look at what happens when we remove bus drivers or train conductors from mass transport. So in Luxembourg, public transport recently, 5 years ago, became free. And the social policy was meant to kind of remove the, well, obviously remove the ticket inspectors from the trains, and kind of turned them into, well, they transitioned to other roles, or they became much more of a just answering questions and making sure that people got on and off the trains safely. Well, and there hasn't been some empirical work that's proven that the behavior of the passengers has changed, but a lot of people have noted that they're seeing or experiencing more conflictual behavior on trains. And so when we go back to autonomous buses, what will happen when we remove this authority figure who doesn't simply drive? They also give directions, they ensure the security of the passengers, and they potentially tell people that their behavior is inappropriate, or assist people with disabilities to get on or off the bus. Now, if we get rid of bus drivers, and if the mood changes in bus as we've seen in trains, there's this risk that little by little people start to choose other modes. So those who have a choice go take their personal vehicle, for example. And the danger here is what you can see in certain cities or suburbs in the UK or in the United States, is where we get a class segregation between modes. And the danger of this is that then certain modes become viewed by decision makers as less valuable and vulnerable to defunding. Of course, this leads to greater social exclusion, right? Because we're really harming those that are already vulnerable who don't have a choice. So that's one concern I have about autonomous vehicles. Another is markets. So clearly, autonomous buses would reduce the costs to operate without a driver. However, what costs will cities pay? Or fares will the public pay? Sorry, cat removal. Consider that autonomous bus operators are likely to be software companies more than transport companies. And we're going to see similar behavior to Waymo or Uber. Fares will be competitive. We're not going to all of a sudden, so going back to this idea of frequency is freedom, how are we going to achieve that where the profits or the benefits are all privatized? So there's a strong likelihood that in the long term, autonomous buses may displace buses with drivers, but once the buses are gone, I think, and we're seeing this in again in North American cities where Uber or wherever displaced bus services, are fares for autonomous buses likely to remain accessible and socially inclusive, or are we start to seeing these software companies or these tech giants start increasing prices? And once a bus fleet is dismantled, there's a very large barrier to redeveloping and reintegrating a bus. So there's this vulnerability aspect that we have to really be careful with. Who are we giving control in order to try and get these benefits? Finally, there's this autonomous vehicle paradox. And I haven't mentioned cars yet, but this is where most attention and most investment is currently allocated. This is the larger market. We're constantly pushed through advertising towards individualization, and individualization is an attempt to enlarge your markets, discourage sharing, and also causes some of the conflict that we see within shared spaces such as buses, right? We're all individualized, we're all in little bubbles, we don't interact with others as much, and this causes conflict. Regardless, the big problem with autonomous vehicles is that they will create more congestion. Rather than parking at your destination, if you have an autonomous vehicle, it'll drop you off at your destination, and then the car will drive home, or it'll drive to some parking lot, or it'll drive to serve another family member for something else. And the cars are going to be traveling more. So this means more kilometers traveled, more congestion. So buses currently already suffer from existing congestion. Passengers are delayed while in some ways being the solution to congestion. And with the rise of autonomous vehicles or autonomous buses, autonomous bus passengers will likely still be stuck in congestion. And even though we talk a lot about autonomous vehicles, we're still going to be stuck in congestion, more likely, and potentially worse. So we really need to have these contentious policy discussions. And cities for the last few decades have always chosen tech solutions because they imagine they can resolve problems without conflict, without having to get these social aspects of like, okay, well, we need to start talking about putting in new lanes or displacing cars or displacing parking. Autonomous vehicles and autonomous buses won't solve issues. They'll likely create many new ones. So if we want to move more people, and we can do it today, not tomorrow, we have to consider reliable policy-proven solutions, such as providing bus lanes or a space for active and human-sized modes. That's it for me. Thank you.
Thank you. Thank you, Cyrille. Thank you very much. We had some very interesting sounds at some time.
Cats probably.
No,
Sorry.
it's fine. Super. Thank you very much. Thank you very much for your intervention. And let's continue with the two Greek representatives in this discussion, in this part of the tonight event. Let's start with Theocharis Vlachopanagiotis, who is the co-founder and CEO of Rhoé.
Cheers.
Haris, go ahead.
Yeah,
The floor is yours.
good afternoon, everybody. First of all, thank you, Fabio and Albert. The presentation was quite interesting. And of course, Cyrille, exquisite as always. And your input, I think, kind of makes my job a bit easier because I'll talk about two things once again, but I will not focus on the social aspect as much. So I will have to slightly disagree, Cyrille, with the argument about autonomous vehicles creating more congestion. So the theory is that, at least established theory, is that a large part of congestion in cities is created by people that are looking for parking spots. So the first idea behind autonomy is that you have shared vehicles. You don't have privately owned autonomous vehicles as much. So you have something like an Uber or something similar where it drives myself and then it goes and picks up another passenger without having to look for a parking spot. So in that regard, some would say that you reduce the congestion first because you don't have as many vehicles looking for a parking spot, but on the other, and at the same time, you introduce the idea of I don't need to have a car for myself. So at least that's the theory behind autonomy. Now let's look at the practice, and I'll take the resilience perspective. So how do we define resilience in urban mobility? When you look at any urban mobility system, right, from a technical perspective, resilience is the response to a disruption, a shock. So if something is fragile, fragile is this glass. If I throw it on the floor, it breaks and it cannot become, like, its state becomes worse because it cannot go back to the state that it once was. Then you have robustness, which is that if this glass was plastic, I would throw it on the floor and it would be the same, right? It could withstand the shock. And then, as Professor Ventikos mentioned, there is the concept of antifragility, which is way beyond most of the urban discussions, but it's what if, of course, it doesn't work for glasses, but what if I could throw something on the floor and it became stronger? Now, if you look at an urban mobility system, right, and you look at is it resilient or not, you look at a few core things. So it's the internal characteristics and the external characteristics of the system itself. The internal characteristics is okay. So let's take, for example, I don't know, the Larissa, the city, right? So if there is a disruption, a bus breaks down, for example, at a major road, first question is, okay, do we have another bus to replace the broken one? Can we accommodate, like offer another solution? And one problem is the city itself, right? Do we have the bus to serve, or do we have smaller buses, or do we have bikes, as the representative from the city of Larissa mentioned earlier, who was with us in the discussion. And then there are the external factors that act upon the disruption and the response itself. So are there more roads that I can take to go to my destination if this one has a broken bus in the middle? Are there enough, is the capacity of the network enough to accommodate people taking other routes to their destination, right? Because you may have like gridlock if suddenly you have a problem in a specific road. How quickly, and this goes into the social aspect, are people acting on this? Is there like an app, like Google Maps, that tells you, oh, there's been a crash there, maybe you should take another road? So all these things define the response to a disruption, right? And the more redundancy, the more options, and the quicker people can react, the better the system responds. Anti-fragile systems in urban mobility are usually seen in aspects where all these three sectors meet. And I'll circle back now into the autonomy perspective. What does it take today for an autonomous service to work? You need a bus with a or a car with a very specific set of sensors that has mapped a very specific set of roads under very specific circumstances. And if any of these are kind of disrupted, so for example, paint is thrown on the road and now the lines are not shown, then you start having problems. So my question is, and this is how I'll close, is okay, we have new technologies, we have a lot of tech coming into our cities. We have to take into account when we implement that, is it contributing to the resilience and the optimal operation of our systems, or is it just us integrating another point of failure that we will have to deal with tomorrow? Yes, autonomy can be useful. Yes, autonomy can be helpful because it allows for more and more things. And but at the same time, I am not yet convinced that we have done the work necessary for it to be implemented at least a resilient way. Thank you. I think I'll leave more space for the questions, and it was glad being here. And of course, before closing, I would honestly like to extend a huge thank you to the organizers of the event for inviting us all and sparking these wonderful discussions.
Indeed, indeed. Thank you. Thank you very much, Paris. Your last question, comment, or whatever, it's very useful. It's something that it keeps on coming. Because sometimes, you know, technology might be there. Is it integrated something? Is it innovated something? Is it when you employ something, what will come out of it? But I guess that this discussion is yet, you know, finalized. Yeah. Thank you. Thank you very much, Theocharis. And last but not least, person in our panel of today is Vasilis Podimatas. He's a senior researcher at the Maritime Research Group at the School of Naval Architecture and Marine Engineering at NTUA, the National Technical University of Athens. So, as you all understood, it's a person from our group. Yeah. So, Vasily,
yeah,
you have like 8 minutes to conclude.
Perfect. More than enough time.
Yeah.
Okay. So, hello to all our colleagues that have connected through this session online. My name, like Professor Vedikos mentioned, is Vasilis Podimatas. I'm a naval architect and marine engineer. And today I would like to give to this session a note from the maritime domain. And I will try to make my case why people working and doing research in urban mobility stuff should care about maritime transport. So in the maritime domain, we are at this very, very nice place where actually implementing autonomous transport, implementing autonomous ships is not that much of a technological problem anymore. That's why when we refer to autonomous ships and the barriers that actually hinder their implementation, we are talking about being a socio-technical issue. So it's not only about having the right number of sensors, the right number of cameras, the right number of actuators and stuff like that. What is most important right now is try to overcome barriers that are connected to society. For instance, the acceptability, the employability. So what will happen if we actually employ autonomous technologies? Will it, reduce the workforce that are actually employed in the maritime domain, or will it actually create better jobs for them? Now, the reason why this is very, I forgot another important point, which is, of course, the business models regarding the implementation of autonomous technology. So it will not be enough, it will not be sufficient to actually use business models that are applied right now in maritime transport. We will need to develop new ones. So everything I mentioned so far is also applicable to other modes of transport, like urban transport, maritime transport, of course, rail, and even the aviation domain. Now, what I would like to share with you is a very important project, which is right now arguably the biggest project relevant to autonomous ships funded by the European Union, which is called Seamless. Here in this slide, you can see its concept, which I know it can be a little bit too much, but what Seamless is about is actually developing an autonomous service. And how do we intend to actually implement the service? It's by developing 3 substantial pillars, or building blocks, as we call them. The first one has to do with developing technologies that handle autonomous cargo handling. So pretty much a ship going to the quayside and having to autonomously load and unload cargo. Autonomous mooring, of course. A ship has to moor when it gets to the quayside. And autonomous port calling, making arrangements where exactly and when exactly a ship will actually moor. That's the first one. The second one has to do with developing a logistics platform that is capable of handling all this traffic, monitoring all this traffic of autonomous vessel put through, and actually dynamically manage any disruptions that might occur, offering this note of extra resilience to the service. And the third one, which is arguably the cornerstone of Seamless, has to do with developing the remote operation centers that are capable of handling these ships. The idea here is to have one operator that will be able to monitor and control the operation of multiple vessels. In our project, it is one operator that will be able to handle 3 vessels. So these 3 building blocks are at the heart of this project right here. Now, Seamless will also offer 2 demonstrators. So there will be a demonstrator of the autonomous navigation technologies in Norway. One will be in Norway. The second one will be in Central Europe. So this will be an effort to cover as much of Europe as it is possible. And last but not least, I should mention that this project is coordinated by our research group at National Technical University of Athens. Professor Vedikos is actually the coordinator. And would be more than happy if you could follow our project. It's called Seamless. And of course, follow our research group, which is called the Maritime Risk Group. That's it from my side. Thank you.
Thank you very much.
Thank you.
Thank you very much for the English presentation. At this point, I would like to thank everybody, all the participants in this panel, for their presentations, their interventions, their talks. So we have like 5 minutes for questions. we can have questions from the room or from the connected people. I see numbers coming and going. I don't know now how many are still connected. But if you want to ask something, you can raise your hand and we will give you the floor. The same goes also here. In the meantime, because I don't see any activity, I would like to ask Theocharis if you can give us an example for here, for Larissa, for autonomous, transport, I don't know, buses or what? Could you see a system here?
Yeah, thank you, Professor Vedikos. That's a very good question, and I think so autonomy currently, because it's not operational, right? And actually, it was a question that I wanted to ask you because you guys work a lot on autonomy. How you defined sustainable mobility? I would like you, if you can, to define autonomy and autonomous mobility as well. What I would say is, at least under the scope of urban mobility, we are not yet at the point where we can just throw a bus in any city. Larissa itself, of course, is a part of that, and say, okay, now it works. It has to do autonomy because, okay, any city has a lot of externalities, kids playing around, different trees, whatever. So you need to minimize the the potential disruptions that might come into your system, right? So if I was to place a bus service, I would make it a standard route, maybe one that goes around the city center, which has less people, maybe it's clearly demarcated more easily. And I would make sure that hopefully it worked on a dedicated lane. Anything else that you introduce kind of sacrifices the resilience of the system itself, if it were up to me.
Thank you. Before giving the floor to Fabio, Theocharis, would you see like a network? I mean, what I mean is not all buses should not operate in an isolated way, but they should create a network so each of them could understand what is, in front. If something goes wrong, to go a little bit faster and cover, I don't know. I mean, I guess that we're not talking about one bus on its own, but we're talking about a network cooperating.
Yeah. Okay. Personal anecdote. I won't name names, but I'll say a city that I know very well has implemented a system where they track if the bus itself is on time, delayed, or is ahead of time. And they can send the notification to the driver, it's not autonomous, and tell them, okay, maybe you need to go faster and slower. Half of the drivers don't respond to the notifications or close the system completely. So yes, the dream is that we can have a system that does not have a human factor and everything can work together. But we're not there yet. When we are, you can introduce a lot of optimization, but it's still very, very far off.
Perhaps we can imagine the city, perhaps. Fabio, the floor is yours. Yeah.
So thank you very much. I do not have a question. I would just like to add up on what has been said so far. I agree with my colleague in a sense that I believe that the first question that we should ask is, do we need autonomous vehicles to fulfill the need that we are looking for? Is it something of a buzzword or if it's really an adaptable solution? So I think the first question that we need to ask is, what is the use case in which we are trying to solve? And then what would be the most adapted solution in terms of the transport offering? And of course, this can, no problems at all be an autonomous vehicle if that's the case, but it could be a human-driven one. And I agree as well in a sense that today the technology is not there. So I've participated in the past in different other projects in the European context, and all of them in the pilot phase, meaning that, yeah, we are advancing, but so far we remain in constrained areas with fixed route, with looped and closed environments. So the better, let's say, the more we have of these projects, the better. So this would allow us to advance the technology, to advance the legal framework, and to have better public acceptance, in a sense that the general public will be more in touch with the technology itself. But I believe that the question that we should first ask ourselves is it, do you see having this kind of service in Larissa or not? I would make the question differently. What is the use case and what kind of solution we could use it for? So I would just like to make this little point.
Thank you very much. Yeah, you can have. We have an intervention from the group.
Okay.
So go ahead. Yeah.
Anyway, hear me. So thank you very much. I'm here today, and let's say from the side of the audience, I heard so many nice ideas. I met people that are doing some great work. I heard about projects, but immediately I felt like want to taste all this in practice, to see them being implemented. So I just have a question. If not the government, then who could be your potential customer? Maybe the municipal or someone else. If not government paying for this, then who could go for it? Thank you.
Yeah, thank you very much. I guess that this question goes more to towards the land side, because for the sea side, I mean, the customer can be all companies, ship management companies, many companies, port state control, port states, anybody more or less. But for the land side, it can be everybody can have an autonomous car at some point, but it's very far away. But who would be the first customer?
Okay, I think maybe I'll add, and maybe Cyrille and Albert and Fabio can add. So we had the same question 15 years ago with electric vehicles, right? So very cool, looks nice. Who is buying that, right? And the idea, at least at that point, was, okay, governments or a very big corporation, Tesla, will fund the first network of charging stations because you need the infrastructure. And hopefully, fingers crossed, people will come. It kind of worked, right? And now you have companies putting charging stations and other companies, many companies making electric cars. So if we're talking about autonomy, for example, I think it starts with governments, for better or worse, making a baseline case for this. So I know that many of us here know that in a nearby city, Trikala, there was an autonomous bus that, I mean, everyone in Greece knows it. It crashed at some point. I know it also, but that's also newsworthy. I mean, maybe that's why it's famous, but there's no bad publicity, as they say, right? So yes, this is why many of these projects are European funded, national funded, because you need some startup capital to make a case. And hopefully it's a convincing enough case that things can pan out. That's my take. It worked for electric vehicles. It worked for, I don't know, smartphones in the past. It didn't work for many things, but hopefully that's where we can go in the future.
Thank you. I don't know whether somebody can add on Theocharis' reply. Cyrille, perhaps you can have a remark or not?
I mean, I think my argument was kind of saying, like, we can get effective mobility today with just some policy changes. I mean, we're not at the stage where the technology is gonna happen in the next, I don't think, in the next 2 to 3 years, anyways. But I think if we really want to move people effectively, inclusively, it's just policy change. It's just putting some bus lanes, having those hard discussions about the problems with too many vehicles, too many cars. It just doesn't work. In the urban center, I mean, I'm not trying to take away people's cars. I'm just saying it's not effective in a dense urban agglomeration.
Okay. Okay. Thank you. Albert, do you want to say something also on that? What? I don't know. Nope. That's nice. Okay. Since we are already 10 minutes past our 8:30 deadline, so I would like to thank Albert, Fabio, Cyrille, Theocharis, and Vasilis for their very nice presentations. And let's hope that in our next meeting, we will have something to add and report something more. Thank you very much.
Thank you, everybody.
Thank you very
Nice
much.
being here.
Have a good evening.
Thank you.
Have a good evening, everyone. Bye.
Yes, bye-bye. Bye-bye.